Okay, hi, welcome back. This is just a quick explanation of how you can sort a you can implement a sort algorithm as a flowchart. This is not it's not the best way to do your sort. If you want to really understand sorting, look up things called bubble sorts or I'm trying to remember the other ones. I can't remember, man. But just look up the various sorting algorithm and their efficiencies. But that's the business for another day. In this one, I'll just show you how you can do a quick sort um, on with my own method, right? So if you look at what we are doing here, we're developing an algorithm that is in three numbers and write them in sorted order. So let's assume that we have three numbers x. Okay, are you not working? X. I think you're white. Okay, yeah, so that should work now. So this should be x, y, and z. So these are three numbers. Let's say the first one is 3, the second one is 5, and the third one is 2. Now what we want to do is we leave our numbers as they are. I'm creating three variables and I'm just assigning them a, b, and c, right? So what I want to do is I want to start testing. I'm checking if a is greater than b. So if a is greater than b, we want b to be first. Is that correct? Because the goal at the end of all of this, what we should have is 2, 3, and 5. That's our end result. That's what our end result has to be, right? That means that if a, which is 3, is greater than 2, greater than 5, what should happen? What I want to do is I want to bring 5 before 3. So let me put them in a box, in 3 different boxes. So first pass, 3, 5, and 2. So if this is greater, what happens is it takes this one and brings to the left. But since it's not greater, 3 just remains on the left, right? Then we go to the next one. Is 5 greater than 2? Yes. If that is the case, if 5 is greater than 2, what you want to do is, so the first pass will be 3. Oops. Sorry, let me undo that. This will be 5 and this will be 2. First pass. Now it comes to the second pass, which is it tests 5 against 2. And what happens if 5 is greater than 2? It brings 2 to the left. So this becomes 3, 2, and 5. Make sense? Then it does our pass over again and checks this. Is it greater? Yes. If it is greater, what happens? It does 2, 3, and 5. If it does this test again, is it greater? No. And then it can stop. So this is technically what we want to do. Something like this. Sorry about this. And that's what we want to get here. This. So this thing I've just done about the testing and all of that, for this to happen means, let's pick this first one that we did a test about. If 3 is greater than 5, what should it do? It brings 5 to the left, right? Bringing 5 to the left is us saying, so this is now say if a is greater than b, I want to bring b to the left. So what that means, if you look at what I have here, that's what I have in this place. If a is greater than b, right, it makes temp. So we are just holding a as a temp because we want to replace the value. Then we make a is equal to b. Now what that means is that in this case a is 3, b is 5. If I make a equal to b, I have made a 5. Is that correct? Yes. So that we don't lose the value of a, what we did was that we took a temporary value, a temporary holding variable, and we assigned it to be 3. So in this case, our temp is 3, a is 5, right? Then what's the next one? B is temp. So B here is 3 because temp is 3, right? So you can continue like that and keep the sorting in the way you want it, right? I think I even made an error. This should actually not be greater that should be less. I'm going to have to fix that. And that's because this part, my algorithm was sorting in reverse, in descending order instead of ascending order. But I will fix that and we should be good. All right. Cheers for now. I hope you understand this. Right. Okay. Let me see. Yeah, I think that's it.